In this module, we'll focus on getting useful, predictable work from large language models by changing our prompts, not the model itself. You'll learn practical patterns for chatting with LLMs and calling them from code, so they become reliable collaborators instead of unpredictable black boxes. You've already seen why sequence matters, how transformers work, and how to fine-tune them with Hugging Face. Now we shift perspective. Instead of touching model weights, you'll learn how to shape behavior through prompts, and then connect that to real-world LLM applications. Decoder-only models are essentially powerful next-word guessers. They read all previous tokens, use self-attention to weigh what's important, and then output a probability distribution over the next token. One token is chosen, added to the sequence, and the whole process repeats. Because each step depends on everything so far, early tokens act like momentum. A small change in your prompt, or a different temperature, can send the entire continuation in a new direction. In code, decoder-only generation follows a simple four-step loop. First, load a pre-trained model along with its tokenizer. Second, tokenize your prompt so the text becomes token IDs the model understands. Third, call generate, where the model predicts new tokens one after another conditioned on your prompt. Finally, decode those IDs back into readable text and strip special tokens. From your point of view, you supply context. The model continues it. Length control acts like guardrails around generation. Length or max new tokens gives you a hard ceiling, so the model doesn't ramble and your costs and latency stay predictable. Min length does the opposite. It forces the model to say at least a bit more, which is useful for explanations, narratives, or structured answers. On top of that, stop tokens or custom stop strings let you cut off output cleanly at specific markers. Temperature and sampling determine whether your model behaves like a careful accountant or a playful writer. Greedy decoding, or very low temperature, keeps picking the single most likely next token. That's ideal for precise answers, summaries, or code, but it can feel rigid or repetitive. Higher temperature and top P sampling widen the choice set, allowing lower probability tokens to appear. That adds diversity and surprise, which you want for brainstorming, creative writing, or exploring alternative ideas. A prompt is like giving clear instructions to a smart coworker. You describe who they should be, what you need, and how the answer should be structured. For example, you are a helpful coding tutor. Explain transformers in 2 short paragraphs for a Python beginner using bullet points. That level of specificity consistently beats vague, one-line requests. Few-shot prompting works like a tiny training set embedded inside your prompt. Instead of just saying format this, you show a couple of inputs with the exact outputs you expect. Then ask the model to continue the pattern. This is especially useful for consistent JSON, tables, or custom labels. The trade-off is more tokens and higher cost, but you often earn that back through more reliable outputs and less cleanup afterwards. Constraints turn a fuzzy model into a predictable component. Spell out exactly how to answer, the format, length, and what to exclude. You might require 3 bullets, under 100 words, no code, or a specific JSON schema. You can also define what to do when it's uncertain, such as replying with, "I'm not sure." These guardrails reduce hallucinations and make integration, logging, and automation much more reliable. Hallucinations occur when the model's words drift away from reality, even though they sound polished and confident. Remember, it's predicting the next likely token, not consulting a fact database. As a result, it may fabricate citations, APIs, or statistics that feel plausible but are incorrect. This is especially risky in medical, legal, or safety-critical contexts. Treat outputs as hypotheses. Build workflows where important claims are cross-checked, and explicitly allow the model to respond, "I'm not sure." Language models are highly sensitive to wording because they're matching patterns, not deeply understanding you. A small change like briefly versus in detail can completely redirect the response. If your question embeds a judgment like, "Why is X bad?" the model will often follow that bias. When answers feel off, assume hidden assumptions are involved. Narrow down to one clear question, then iteratively rephrase and tweak your instructions to see how the behavior shifts. Large language models don't invent their own values, they mirror their training data. Any stereotypes, biases, or harmful language in that data can quietly appear in their answers. They also lack real understanding and up-to-date awareness. That means it's on us to ask safe questions, apply judgment, and double-check outputs, especially in sensitive or high-impact contexts. Responsible use is mostly about people and process, not just technology. Treat user data as you would in production. Minimize it, anonymize it, and avoid sending sensitive details to external tools. Be explicit about ethics. No disinformation, harassment, or plagiarism. For anything important, keep a human in the loop to review, edit, and approve. And finally, follow your organization's AI policies so your experiments stay safe, compliant, and trustworthy. Think of your prompting workflow as a tight feedback loop. Start by stating the task clearly and specifying the output format you want. Draft a prompt, possibly with a short example, and choose sensible generation settings. Run it, treat the response as a prototype, and critique what you see. If there are hallucinations, bias, or messy structure, refine your instructions and constraints. In code, wrap this process in reusable functions and log prompts and outputs so you can steadily improve over time. You've now seen how decoder-only LLMs generate text and how prompts steer that process. Clear instructions, good examples, and well-chosen constraints make outputs more reliable, but they still require review for errors and bias. Next, we'll connect these skills to real-world applications, look at trade-offs like cost and risk, and point you toward concrete pathways to keep learning.